Welcome to the e-learning program, the 6 Magnetic Liquid Level Gauge. Upon completion of this module, you will be able to explain the basic principles of the 6 Magnetic Liquid Level Gauge, MLG, and you will possess basic technical knowledge on the principles on which KM26 Magnetic Liquid Level Gauge operates. Understand how Accutrack AT200 magnetostrictive level measurement technology is used with the gauge for liquid level indication. Name the features of the KM26 MLG.
One of the best solutions for liquid level indication and non-contact level transmission and switching is the Magnetic Level Gauge, or MLG. Our KM26 magnetic level gauge can be used in the most demanding process applications, up to 4,500 psi and 1,000 degrees Fahrenheit. The unique extruded outlet process connections and our precision-engineered floats have provided our customers with years of maintenance-free operation and a new standard of performance.
The KM26 magnetic liquid level gauges are manufactured to suit customers' specific process requirements. A hermetically sealed float with an internal magnetic ring is housed in a non-magnetic material float chamber. The float will move up and down in the chamber as level of the liquid rises or falls in the vessel on which it is attached. The floats are designed and weighted so that the center of the magnet assembly is at the true fluid level for absolute accuracy. A magnetically coupled, highly visible shuttle, as seen here, or bar graph indicator, encapsulated in a hermetically sealed glass tube, is attached in a scale housing to the outside of the float chamber. It indicates the liquid or interface level without being in contact with the process fluid. The AT200 transmitters are based upon the magnetostrictive principle. They can be mounted directly to the KM26 MLG chamber to provide a continuous level measurement 4 to 20 milliamp output signal. The transmitter probe contains a wire which is pulsed at fixed time intervals, creating a magnetic field around the wire. The interaction of the magnetic field around the wire and the magnetic float causes a torsional stress wave to be induced in the wire. This torsional wave propagates along the wire at a known velocity, from the position of the magnetic float and toward both ends of the wire. A patented piezoceramic sensing element placed in the transmitter assembly converts the received mechanical torsion into an electrical return pulse. The microprocessor-based electronics measures the elapsed time between the start and return pulses and converts it into a position measurement which is proportional to the level of the float. Magnetostrictive level transmitters are highly accurate devices designed to be used with the KM26 magnetic liquid level gauge. They provide continuous level indication and transmission of an analog signal for monitoring, control, or safety. The unique magnetostrictive design allows increased level sensing resolution, which is more than 100 times greater than a conventional reed switch type sensing device. The magnetostrictive transmitter is a highly accurate technology which can be used with the liquid level gauge. Some manufacturers only offer reed switch contacts in their transmitters. They provide an incremental output signal that many control loops do not work well with. They are also maintenance intensive, since there is a reed switch every quarter inch to half inch. Magnetostrictive technology has a proven record of over 30 years and offers great reliability compared to reed switch designs. Magnetostrictive sensors in the industry employ different designs. All of these sensors currently used create a voltage when the torsional wave from the magnetostrictive effect is sensed. Let's look at these different sensor designs. The first competitive sensor pictured here has two strain gauge-like devices welded to the magnetostrictive sensor. When the torsional stress wave is detected, a voltage is produced at each device when the torque is sensed. This is a very delicate assembly and is likely to break in high vibration applications. The second competitive sensor pictured here is a coil around the magnetostrictive sensor. When the torque moves the sensor, a voltage is produced across the coil. The torque and movement are small, and so is the voltage produced. Simple and cheap, but a voltage is also produced when the sensor moves due to other effects, such as vibration. The third competitive sensor pictured here is a piezoceramic plate resting against the magnetostrictive sensor. A voltage is produced across the plate when the torque is sensed. Again, simple and cheap, but as in the coil sensor, a voltage is produced when the sensor moves due to any vibration. The contact area between the sensor and the plate are much smaller than with the AccuTrack AT200 sensor. The AT200 AccuTrack sensor uses a proprietary piezoelectric design, which improves signal-to-noise ratio and provides an accuracy of 1/50th of an inch and is extremely repeatable. Now let's summarize this learning module. So what have you learned so far? The basic principles of the KM26 magnetic liquid level gauge and how magnetostrictive technology is used with the gauge for liquid level indication and competitor magnetostrictive designs. The features of the KM26 magnetic level gauge.